Okay, welcome back. In this video, we're going to look at some applications of right angle trigonometry, some applications of SOHCAHTOA. As we've done throughout the course, word problems can sometimes be a little bit challenging. Even when we're really good or we feel comfortable with the procedures that we've learned in class, it can be difficult to kind of apply them to real life situations. My advice always, no matter what type of math you're doing, is to try to draw some sort of sketch and then spend a lot of time carefully parsing the question. What are we really trying to find out here? And then what tools can we apply? So in this question, I've got two buildings that are 30 meters apart. From the top of the shorter building, the angle of elevation to the top of the taller building is 28 degrees. And from that same vantage point, the angle of depression to the base of that taller building is 55 degrees. So before we even think about what the question's asking us, why don't we try to draw a rough sketch of this problem? So I've got two buildings that are 30 meters apart. Here's my great art. There's a short building. And then if I travel 30 meters away, I've got some building that is taller. So there's our tall building. The first thing we know is, first of all, that this distance along the ground is 30 meters. If I'm starting here, if this is my vantage point, I think it helps to show where our perspective is. Our angle of elevation to the top of the taller building is 28 degrees. So in class, we talked about the angle of elevation is how much we'd have to rotate our eyes from horizontal up to see something above us. So if you think about looking directly across horizontally, if then I rotate my eyes up, that angle is our angle of elevation. So that angle here is 28 degrees. The angle of depression is, again, start by looking straight ahead. Think about that horizontal horizon line. You can think about those binoculars you put quarters in on Niagara Falls. They start looking straight, and then you have to rotate it down to see something that you're interested in. So here, if I rotate down to see the base of the building, that's the angle of depression there. So be careful that you're labeling your angles correctly. Both the angle of depression and the angle of elevation are in comparison or relative to that kind of horizontal straight ahead gaze. And I'm trying to find the entire height of this building. The challenge is, you notice this triangle is not a right angle triangle. So we don't yet have the tools to solve this in one step. But what you notice I can do is I could break this up into two right angle triangles. I've got one on the top, one on the bottom. So for example, if I call this height x and this height y, I could find those separately using SOHCAHTOA and then add them together, and then x plus y is going to give me the total height of the building, which is what I'm looking to solve for. We also know that if it's 30 meters between the buildings on the ground, it's also going to be 30 meters up here in the air. So let's try to solve for x first. Here's my reference angle of 28 degrees. Again, any question that's right angle trigonometry, I want to start by labeling my sides. I've got opposite, hypotenuse, and adjacent. And so I want to know opposite, I know adjacent. So our first step in solving for x, so let's say solve for x, is to select which trig ratio it uses opposite and adjacent. Well, of course, that's tangent. So tan theta equals O over A. So in this case, I've got tangent of 28 equals x over 30. Doing that over 1 might help you cross multiply. So x is going to equal 30 times tan 28. I'm always multiplying the diagonal that doesn't include the x. And you should be able to punch that directly into your calculator. 30 multiplied by the tangent of 28. That's going to be 16.0, right? 15.95 would round up to 16.0 meters. That's that top height, that extra height to go from the small building to the tall building. Next, we could solve for y. Again, I'm going to start, this is part of a separate right angle triangle, so let's relabel the sides. Across from the reference angle, which is now 55, that's my opposite. My longest side is across from the right angle, that's my hypotenuse. And this 30-meter side, that's still my adjacent, right? It's next to my reference angle. So again, I want to know opposite, I know adjacent. So again, I can use tan theta equals O over A. But in this case, my new reference angle is 55. Now I'm looking down. And that's going to be Y opposite over adjacent, which is still 30. And then when I cross multiply, Y is going to equal 30 tangent 55. We should expect that this length is going to be bigger because I had to rotate my eyesight more to reach the bottom, right? So this should be a longer distance. Hopefully it is when I punch into my calculator. I've got 30 multiplied by the tangent of 55 degrees. And sure enough, it's a little bit bigger. It's 42.3 meters. So I'm not yet done the problem. We wanted the entire height of this taller building, which is x plus y. So that's 16.0 plus 42.3. So overall, that taller building must be 58.3 meters. And because it's kind of a real-life application, let's connect our numerical analysis back to the real-life situation with a concluding statement. So therefore, the taller building is 58.3 meters tall. So that's an example of the type of problem that we can solve with right-angle trigonometry. My advice for you, always draw a sketch. Look for where you see one or two right triangles, right? Everything we're doing with SOHCAHTOA needs to have right triangles. Be careful labeling the information from the problem. I think we're all pretty good at using the ratios. The trick is connecting the sketch to our mathematical toolkit. Remember, of course, your units. Again, and then focus on this idea of angle of elevation is horizontal up, while angle of depression is from the horizontal rotating down. Again, if you have any problems working with word problems or real-life applications, don't hesitate to reach out, send me an email, or ask during study hall. Okay, that's all for now. Thanks again for watching.